Find the surface area generated when the graph of the function y equals the square root of 2x plus 1 for x is between 0 and 3 is rotated about the x-axis. First step in the process is that we need to choose a setup of the surface area integral. When you're rotated around the x-axis, then the general setup is 2 pi times the integral of y ds. It just depends on which variable you want to do it in. If you want to do it in x, that's perfectly fine. Then what happens is the y can't stay as a y. So y will become f of x, and then the ds part will be your normal kind of square root of 1 plus f prime squared. And then if you perhaps would want to do it in y, then the y stays as a y, and then the ds becomes the same version of it, but in terms of y. What you do is you consider what you are given, and you use that as a clue as maybe what you should do. You're given y as a function of x, and you're given an x range. So that's a clue that maybe you should try to do it in x. And we'll see what happens. If it gets bad, we can switch and do it in y. And so in x, we'll go from 0 to 3, replace y by f of x, and then have the square root in terms of x for the ds part. Alright, great. So what we need to do is take this ds part, this 1 plus f prime squared underneath the square root, and simplify it. Step by step. Let's do that. Simplify ds. If your function is root of 2x plus 1, your derivative is 1 over 2 times that same square root of 2x plus 1. But don't forget though, the chain rule has to come into play. You have to multiply by the derivative of the inside. 2x plus 1's derivative is 2. Well, look at that though. If we have 2x plus 1 underneath a root, but then a 2 above and a 2 below, those can cancel each other out. So you just have 1 over the root of 2x plus 1. Well, then we have to square that. But that's nice, the root just goes away. Square of 1 is 1. So then we're going to have to add the 1 to that. So we have 1 plus the derivative squared. Well, you can't leave it as 1 plus that fraction. Why don't you put it as one fraction? So we'll do that and call it 2x plus 1 over 2x plus 1 and combine it with the 1 over 2x plus 1. What we get is 2x plus 2 over the square root of 2x plus 1. I'm sorry, over 2x plus 1. And right before we take the square root though, we recognize that 2x plus 2 here, we can factor out a 2. So we do take the square root, but we can factor out a 2 and then take the square root of that 2 out, just to make things as simple as possible before we go and deal with the integration. Okay, great. So now we just need to plug in to the integral, and we need to integrate. That's the third step. The integral that we had on the first slide was 2 pi, the integral from 0 to 3, f of x, times the quantity of 1 plus f prime squared. Now, we know what f of x is, and we know what this root is. Let's put them in together. The f of x is root of 2x plus 1. The simplified version of the ds, the root here, is the root of x plus 1 over the root of 2x plus 1. And what I did with that root 2 is I pulled it all the way out. So what's going to happen? It's so convenient. We have a 2x plus 1 underneath a root and a 2x plus 1 underneath a root. Those guys are going to cancel each other out. Well, what does that leave you with? Well, then we're left with then just the root of x plus 1. And that's a simple integral. If you need to do a u sub, let u be x plus 1 because du is just dx. And then what we do is we take the 2 root 2 pi that's on the outside, and then we integrate u to the half and get u to the 3 halves, but times 2/3. Putting that all together, what we're looking at is 4 root 2 times pi all over 3 times u to the 3 halves. And this is all scratch work to help us figure out what the antiderivative is. It's exactly x plus 1 to the 3 halves times that constant that we had, 4 root 2 pi over 3. And it's from 0 to 3. So we put a 3 in, we put a 0 in, and we end up with 4 to the 3 halves and a 1 to the 3 halves. And we subtract. Now remember, 4 to the 3 halves, that's just 2 cubed. 4 to the 3 halves, you treat it as 2 squared to the 3 halves, so we end up with 2 cubed. This is 8. So 8 minus 1 is 7. Final answer then, take the 7 that's here and multiply it by the 4 and call it 28 root 2 pi all over 3. What's your final answer?